Okay, so we've been looking at solving quadratics. Now, the solutions to quadratics, so your answers, your x values, can also be called roots, okay? And so what they really mean, if we get two answers, our graph looks something like that, where it crosses the x-axis at 2 points. There were times then that you only got one answer, and that means that the graph only hits the x-axis at 1 point. And then there was times when we were doing the graphs, drawing them by completing the square, they weren't crossing the x-axis at all. So now there's a special word, the discriminant, that refers to part of the quadratic equation, b squared minus 4ac. And what happens is, you're always told at GCSE, oh, if that's a negative number, you've gone wrong somewhere. That wasn't strictly true, but it's where these graphs come from. So if b squared minus 4ac is greater than 0, so it's a positive number, you get two solutions, and these are called two real roots. And sometimes you'll see two real distinct roots. So for this one here, b squared minus 4ac equals 0. These are called repeated or equal roots. And for our last one, this is where you would have got the question at GCSE and would have said check your answer. When b squared minus 4ac is less than 0, so you get a minus underneath the square root sign in a quadratic equation, in the quadratic formula, that means you've got no real roots. So in other words, it doesn't cross the x-axis. Okay, so the sort of question that you could get, state the type of roots for the following equations. X squared plus 2x minus 2. So we want to find just b squared minus 4ac. So we're not asked to find the roots, we're just asked to find the type. So b squared, that's 2 squared, minus 4 times 1 times minus 2. So 2 squared is 4, this becomes plus 8. So that's 12, that's obviously greater than 0, so therefore there's two real distinct roots. Our second one, x squared minus 3x plus 39 equals 0. So b squared minus 4ac for this one here, that's minus 3 squared minus 4 times 1 times 39. Minus 3 squared is 9. Minus 4 times 1 times 39. That's going to give us minus 156. So that's minus 147. That's obviously less than 0. So therefore we say it's got no real roots. And our last one, x squared minus 4x plus 4 equals 0. So we have minus 4 squared, minus 4 times 1 times 4. So we'll get 16 minus 16, which is 0. So therefore we get repeated or equal roots. Okay, so our slightly harder type of question there, and this would be a more typical exam question. So given that the equation kx squared plus 8x plus k equals 0, where k is a positive constant, has a repeated root, find the value of k. So try and get in the habit of the first thing you write down. So we're saying repeated root, so that means the discriminant b squared minus 4ac equals 0 for a repeated root. Okay, so it shows the examiner in your paper that you know what you're talking about. So we've got b is 8 squared minus 4 times our a this time is k, or c is also k. So So we get 64 minus 4k squared equals 0. And we have to solve that. So we get k squared is 16. And then you would take the square root, and it says it's a positive constant. So k would be 4. Okay, next one then, number 3. The equation 4x squared minus 3x minus q plus 2 equals 0, where q is a constant, has no real roots. Find a set of possible values of q. So again, get in the habit of saying, okay, for no real roots, what is our rule? Our rule is that b squared minus 4ac is less than 0. So b is minus 3 squared minus 4 times a, which is 4. And then just be careful, this whole constant here is your c. So it's minus q minus 2. You can't just ignore the minus sign in the front there. So we get 9 minus 16 upon minus q minus 2. So that's 9 plus 16q plus 32. So we get 16q is less than minus 41, which means q is less than minus 41 over 16. And our fourth one then, the equation kx squared plus k minus 2x plus 2 equals 0 has two distinct roots. Find the range of values k can take. So again, you should be looking two distinct roots. B squared minus 4ac is greater than 0 for two distinct roots. So where b is k minus 2 squared, minus 4 times a is k, and c is 2. So multiplying that out, we get k squared minus 4k plus 4 minus 8k is greater than 0. So that's k squared minus 12k plus 4 is greater than 0. So now this doesn't factorise, so we need to use the formula. So minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And this cancels to give our two answers of 6 plus or minus 4 root 2. So now this is a quadratic inequality. So remember, we'll have to sketch a graph to find the range of values in a quadratic inequality. So our 2 points, this is 6 minus 4 root 2, this is 6 plus 4 root 2. It's a positive quadratic, so it's around this sort of shape. We want where the graph is greater than 0. So that's in this area and in this area. So our answer would be the k would be less than 6 minus 4 root 2, or k is greater than 6 plus 4 root 2.